Hello, this video is going to be for the z-test for the mean. I will remind you before we even begin that we can only use the z-test for the mean when we know the sigma. So remember the sigma, this business over here, this is the population standard deviation. If we don't have this population standard deviation, we cannot use it. Okay, we cannot use the z-test, population standard deviation. So we can only use our z-test over here only if we know the sigma. So we are going to do this. We're going to go ahead and use the z-test, and the test value is calculated in a very similar way, just like we calculate the z-values. If you remember, the z-value was just x minus mu divided by sigma, so this is very similar to that. We are going to talk here, the observed value, this business over here, the observed value is going to be our statistic, such as sample mean, and it's going to be computed from the sample data. The expected value, this expected business over here, is going to be the hypothesized population statistic. Okay, I think that the mean is 45. Okay, so this is something that I expect. I expect that this is going to usually come from the null, okay, that we have this expectation that the null hypothesis is true. And the denominator is going to be the standard error of the statistic being tested. So if I have a mean of a sample, right? So if I have my x bar, remember that the sampling distribution of a sample mean is going to be distributed normally if I have either that I know that the population is normal or my n is greater than 30. Once I know that, then I know that it's going to be the mean of x bar. The mean of the sampling distribution for sample means is actually going to be the mean of the population. And then the standard error of x bar is going to be the standard deviation of the population going to be divided by the square root of n. So once I put all this in, right, I'm going to end up with my test value looking like my z-test value is going to be, this is what I got from my sample. My x bar is what I get from my sample. My mu is the expected value from my null hypothesis. And then the standard error is going to be this variability of the sampling distribution for the sample means. And that is what I am going to have there. And then I'm going to compare that to my critical value as I go along. Okay, so essentially this is what we're going to have there. And again, this is my sample mean. This is the hypothesized population mean. This comes from the null hypothesis. This is the population standard deviation. And again, I can only use this z-test only if I know the population standard deviation. And I'll remind you from the previous chapter that if we do not have it, then you will have to go to the t-test. Okay, and the first step for testing a hypothesis is going to check the assumptions have been met. And we talked a little bit about this, and we will continue reminding ourselves that we first of all need to make sure that our sample comes from it's a random sample. Okay, sample is random, that we follow some kind of a healthy sampling procedure, that the difference that we might have, the variability that we might have is only coming due to chance. Okay, there is chance that it's going to vary, but that chance should be a chance, not a bias. Okay, there is a chance of a type 1 or a type 2 error, but we need to make sure that this is due to chance. So when the difference is statistically significant, the null hypothesis is going to be rejected. And the significance is going to be the chance of making type 1 error. I remind you, we discussed this in previous videos. So in a one-tailed test, you're going to have some kind of an area, and that area going to be separated by the critical value. And this region over here, this region, we're going to say this variability happens due to chance. Okay, this is we fail to reject. This region over here is fail to reject the null. Null is okay. Okay, but from this region, from this critical region, we are going to be rejecting. We're going to reject the null here. Okay, and this whole assumption is due to we're thinking all of this distribution is that the null is true. And this area, this critical area, by the way, here, we might be making a type 1 error. Okay, this is type 1 error area. Okay, and my alpha is going to determine the highest value that I am willing to commit this error.